Vary is a statically typed language that measures test strength. Writing code is not the hard part anymore. The problem is now knowing if that code works. Vary puts testing and correctness into the language. Static types, contracts, built-in tests, and mutation testing in one CLI. It helps to find poor tests in generated code, even tests that lie. AI coding tools will write your code and your tests. The problem is, they may not be doing what you think they are doing. They produce tests that look thorough, pass cleanly, but check nothing, and in fact make things worse by giving you a false sense of security. Here, assert true is set to true and ignores the result entirely. This test will pass no matter what login returns. This one checks if the result is non-empty or empty. That means it's always true. It's a tautology and tests nothing. This test just returns 0. There's no assertion at all and the test does nothing. And this only checks that the output is non-empty. It would still pass if the hash function returned the word hello every time. 4 tests, 4 green checkmarks, 0 confidence. The gap between tests passed and tests proved something keeps growing. Vary works to close this gap. One command installs the toolchain manager and the latest compiler. Vary compiles to JVM bytecode and runs anywhere the JVM does, so mutation testing uses bytecode patching and mutants run without the needing to recompile the code. This is a huge speed advantage. Tests can lie, but mutation testing exposes the ones that do. Vary's mutation engine makes small, controlled changes to the compiled bytecode and reruns the tests. If a test still passes after the code changes, that test is not checking what you think it is. Vary mutate shows which tests are weak, which mutations survived, and what to fix. Coverage tells you which lines ran. Mutation testing tells you whether your tests would catch a real bug. Contracts declare what a function expects and what it promises. In checks preconditions. Here, the amount must be positive and not exceed the balance. Out checks post conditions, the result must be non-negative. Observe assertions check behavior at runtime inside tests. All of this is in the language itself. Both tests pass. Contracts and tests live in the same file as the code they verify. The lie detector classifies every test as placebo, lie, gap, or OK. Placebos have constant assertions such as observe true. This can never fail, no matter what the code does. Observe 1 equals 1, same thing. The test exists but checks nothing. This is a lie. It checks that the trade price is greater than 0. It would pass if the price were 1,000,000 or if the code used the wrong price entirely. Gaps reference runtime values but do not cover the specific mutation. The test checks that trades exist, but not what they contain. The lie detector flags placebos, lies, and gaps so you can fix them before they reach production. The fix is to write what you actually mean. Pin exact values, test boundaries. The lie detector scores these tests as OK because every proof mutant is killed. If you have used Python, Vary will look familiar. But it's not Python, it's Vary. It uses braces for blocks, static types with inference, and compile time null safety. Readable code, but the compiler catches mistakes before anything runs. Optional values use question mark types. Null checks narrow the type at compile time, so missing values are handled explicitly. Data types give you immutable value objects with no boilerplate. Equals, hash, and string representation are generated for you. Top-level code runs directly. No main function, no boilerplate. Run, check, test, format, and mutate from a single binary. Everything ships with the compiler. There's nothing else to install. Check out Varylang.com for the docs and language tour. Generating code is easy, trusting it is not. Vary is a lie detector for your tests. Static types, contracts, built-in testing, and mutation testing in one language, so your software has to earn confidence, not assume it.